So I had somebody ask me about just simplifying various algebraic expressions. These all have to do with exponent laws that we've worked on. So this was what we worked on in chapter one. So we had four different expressions. We had, let's see if that works. Just a second, get you out of the way. There we go. So the first problem looked like this: 10x to the third times 3x to the fourth over 2x to the negative 6. And so you got to think of them as different pieces. Think about the numbers the unknown numbers, and treat them as different things. So really I can go 10 times 3 over 2. And so I know I'm going to have 15 because 30 over 2 is 15. I could also have done 10 over 2 first and gotten 5, and times 3 and gives me 15 anyway. Then as far as the x's go, I have x to the third times x to the fourth. So I actually end up with 7 of them. X to the third means you've got x, x, x. X to the fourth means you've got x, 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 x. If you count that up, you've got 7 x's all in a row on the top. The bottom is x to the negative 6. Then I focus on x to the 7 divided by x to the negative 6. Just like we just saw that when you multiplied x to the third and x to the fourth, you added the two powers. Well, the opposite of multiplying is dividing, and the opposite of adding is subtracting. So here I'm going to go x to the 7 minus negative 6, which is the same as adding x to the 13th. So that's as simplified as part A can get. Part B becomes x squared times 4x to the negative 3 over x to the negative 1. The only number in the problem is 4, so I know I'm going to have a 4 at the end. I'm going to do the tops together. 2 plus negative 3 is negative 1. Just rewrite the bottom. And then I'm going to subtract top power minus bottom power, negative 1 minus negative 1, which is 0. So I have 4x to the 0, and x to the 0 is equal to 1. So I really just have the number 4. Now, many of you might go back here to this step and say, okay, it's the same thing on the top and the bottom, so all that's left over is a 4. And if you want to just jump from that step to the end, that's totally fine. Part C is a big old square root. 3x to the third times 12x to the 0 times 4x to the fifth. So let's just do those. 3 times 12 is 36. And I'm just going to scoot the 4 to the front. You can rearrange the order when things are being multiplied. So I did 3 times 12, and then I'm just going to bring the 4 right up there. And then I've got x to the third times x to the 0, so 3 plus 0. And I've still got an x to the 5. Really, you could have done this in one step, where if you just do 3 times 12 times 4, all is one step. I'm just breaking it down in steps. Then 36 times 4, let's see, that's 120 plus 24, so 144. And then x to the 3 times x to the 5, that's x to the 3 plus 5. And then the square root is the same as the 1/2 power. It's what number times itself makes 144, 12. What number times itself makes x to the 8, x to the 4th. Doesn't get any better than that. Last but not least, we've got x to the negative 2 raised to the 5th, x to the 3rd raised to the negative 4th. Here I've got a power raised to another power, and so that becomes x to the negative 10. And the same idea on the bottom, x to the negative 12. When you have a power raised to another power, you multiply those two exponents together. And then I have division, so like I've talked about a few times, we go top power minus bottom power. Double negative becomes a positive, so we have x to the second power. And that's it. Please let me know if any of those are confusing, or if there's anything else that I can do to help. Thanks for watching.